everyone. In the previous video, we have seen principle, construction and working of scanning tunneling microscope. And in the same video, I told you that G. Binnick had developed another tool, that is atomic force microscope, in order to overcome the disadvantages of STM. So this atomic force microscope, abbreviated as AFM, is very high resolution type of scanning probe microscope. Its resolution is higher than that of STM. It can be used for all types of surfaces including polymers, ceramics, glass and even biological samples. It was invented by G. Binnick, Kate and Gerber in 1986. And it is based on the principle of interatomic forces, that is van der Waals forces. Okay, so let's see this animation available on YouTube for the working of atomic force microscope. Okay, now suppose this is the sample surface. You can see here this hills and valleys. It is nothing but the atom and void on the sample surface. This is again atom. And this is the cantilever, and the main important part of the atomic force microscope is tip. Okay. So this tip is made up of silicon or silicon nitride. It is a very sharp tip, and this tip has radius of 20 nanometer at the apex. As you can see, the top surface of this cantilever is highly polished and a laser beam is obliquely incident on this cantilever. So this polished surface reflects this laser beam. Now you can see, as the tip is moving on this hill, okay, the position of this reflected laser beam changes. You can see here, and when it is on valley, again the position changes, right? So as the tip is moving on hills and valleys, it will be deflected in downward or upward direction, and then the position of this reflected laser beam changes, and thus the position of hills and valleys on the sample surface is detected. Okay, so this is the diagram, block diagram for atomic force microscope. As I told you, this is the tip, important part, made up of silicon or silicon nitride. Radius is of 20 nanometer. This is cantilever. The length of the cantilever is of the order of few micrometers. The laser is obliquely incident. Top surface is highly polished. The beam is reflected. Now, when the distance between tip and sample surface is less than 10 angstrom, then and then only van der Waals forces becomes activated. Now, when the tip is over hill, that means over atom, then distance between tip and surface decreases. As the distance decreases, van der Waals forces of repulsion act on this tip. As the tip is repelled, that means deflected in outward or upward direction, the reflected laser beam changes its position. Okay, so it may come here. When the tip is moved and it is on the valley, that means void, distance between tip and surface increases. Now van der Waals forces of attraction act on the tip, and the tip is pulled towards the surface. That means it is deflected in inward direction. As the tip is deflected in inward direction, the position of reflected laser beam changes, and thus based on this beam is then detected by the position sensitive photodiode array, and thus based on this, the position of hills and valleys, that means atoms and voids on the sample surface, is detected. So as I told, Using this atomic force microscope, we can study all types of surfaces, all types of materials. Okay, so I hope you have understood this construction principle and working of AFM. Thank you so much.